CBC News. Here we are, witnessing the death of a jellyfish after its collision with a cartilaginous fish. Authorities say that the cause of the death was due to its lack of bones. Now let's meet the specialists and figure out the evolution of skeletal system of all chordates.
Landslide. What provides landslide support is not a backbone but a notochord, which is a cartilaginous skeletal rod. They don't have bones, but the gills and fins also contain stiff supportive rods. Landslides have dorsal, caudal, and ventral fin, but no pair fins. However, they have metapleural folds along the sides of the body, which are precursors of pair fins. Landslides are as developed because they are streamlined animals and live half buried in sand most of the time. Tunicates. Young tunicates have a notochord, but the adult's body has a tough covering called the tunic. It functions as an external skeleton with additional support provided by body fluids and connective tissues. Tunicates, like landslides, do not have bones either as a young or as an adult. The skeletal system of a fish is either composed of thin and flexible cartilage or hard calcified bones or both. The functional units of the fish skeleton is head skeleton, vertebral column, tail skeleton, unpaired fins, and paired fins. Head skeleton consists of cranium, jaws, opercular apparatus, and gill arches. Cranium surrounds brain and supports sense organs. Opercular apparatus is a bone on each side of the fish that covers the chambers housing the gills. There are different types of jaws depending on what the fish has adapted itself into eating. Fish with superior mouth are normally ambush predators, hidden to attack their prey once it appears above their longer lower jaw. For a terminal mouth, both upper and lower jaws are the same length. Fish with these jaws are typically midwater feeders and omnivores. Bottom feeders, which feed on crustaceans or shellfish, have an inferior mouth, meaning their upper jaw is longer. Jawless fish eat small particles of food that they filter out of the water or suck up like a vacuum. Gill arches are 3 pairs of bones that are made of bony filaments to aid gills. In the vertebral column of a fish, because they are least developed chordates, notochord remains throughout life surrounded by centrums. Neural spine stretches to support the dorsal side and the hemospine stretches to support the ventral side. The neural arch encloses vertebral foramen and the hemal arch encloses the caudal vein and dorsal aorta. For the tail, the shape can be an indicator of how fast a fish usually swims. There are several different types of tails. There is protocircle tail, heterocircle tail, homocircle tail, hypocircle tail, isocircle tail, diphycircle tail, and gyrocircle tail. Fish with a deeper fork swim faster. Fish with a rounded or flattened tail are a slower swimmer. Fish with a continuous caudal fin are able to swim in round cracks and crevices. Amphibians generally have calcified bones to support their body weight under the force of gravity, a skull that is light and flattened for both motility on land and a streamlined shape for moving easily in water, and pectoral girdle adapted to give support for the forelimbs which absorb the body weight when landing after a jump. To be more specific, salamanders have bones that are adapted for walking such that fore and hind limbs are the same size. Their long vertebral column isn't ossified. Their skull has an extra set of articulation with the vertebrate column for stabilizing the head on the vertebral column. Other amphibians have developed a specialized trunk to meet this challenge. A big example would be a frog, which is adapted to swimming and leaping. Hind limbs, which are for jumping, swimming, walking, running, and climbing, are much longer than forelimbs. Although forelimbs may be short, they are robust. They have a reduced tail and skull shows the pedicellate teeth, a feature of all amphibians.
For the class reptiles, the complexity of its skeletal system varies from one species to another. The skeletal systems of snakes composed of the skull, vertebrae, and ribs are simpler, whereas the skeletal systems of crocodiles are more complex, as it is made up of more vertebrae and bones, such as the caudal vertebrae, femur, and tarsus. In comparison to fishes and amphibians, reptiles have developed larger skeletons so that they could hold larger organs and help them increase in size. Another noticeable difference between the skeletal systems of amphibians and reptiles can be spotted in their skulls. To elaborate, many reptiles have developed joints in the skull, permitting kinesis, a capacity for slight movements within the skull. This is a crucial adaptation for the class of reptiles as it increases the gape of their mouths, enabling them to swallow their large prey. In addition, reptiles have little specialization of dentition, with their entire tooth row made up of conical teeth, unlike mammals whose tooth row consists of various teeth, including blade-like incisors, tusk-like canines, and flat-crowned molars. They're equipped with one type of teeth, as larger carnivorous reptiles are only required to tear off large pieces of their prey, and the majority of reptiles swallow their prey without grinding or chewing. Moving on to the class of aves. My favorite. Birds, without a doubt, has a significant number of differences in their skeletal system compared to all the other classes of the phylum Chordata, for obviously its main purpose of adapting to their disparate habitat, the sky. To begin, due to their need to support their body weight up in the air, birds have a lightweight skeleton with most of its bones being pneumatic, meaning they're hollow and filled with air spaces connected to the respiratory system. Going along with this circumstance, the bones inside the skull of birds are generally fused together to make these species even more lightweight. And contrary to the heavy-toothed jaws of reptiles and amphibians, birds have a replacement of a light, toothless beak. Second, birds have developed to have more cervical vertebrae than any other class in the phylum Chordata, as an essential adaptation for body maintenance and eyesight. To explain further, the avian forelimbs is almost useless for any task other than flight. And so, to make up for this lack of forelimb ability, the long flexible neck makes it possible for birds to use their beak to preen feathers in areas hard to reach like the back and tail. On top of this, due to the disadvantage of having immobile eyes and head movement, a flexible and long neck is required to focus on objects at various distances. Finally, the class with the best-looking species of phylum Chordata, class Mammalia, with the most complex skeletal system of all. Welcome. Let's commence. So, although the number of bones slightly vary in mammals, the skeletal system of every mammal follows this basic plan. Their skeleton is divided into two portions, the axial and the appendicular. Basically, the axial skeleton consists of bones along the axis of the body. This includes the rib cage, the vertebral column, and the cranium. This portion of the skeleton functions to protect the nervous system. On the other hand, the appendicular skeleton consists of the bones of the appendages, including bones like the humerus, ulna, tibia, fibula, etc. And it also consists of the pectoral and pelvic girdles that connects these forelimbs to the axial skeleton. Mammals live in a wide range of habitats and require different characteristics for survival, but the basic plan of the mammalian skeleton has the same goal, which is to support the numerous muscles and ligaments they have, and to also protect their organs. Species in this class have developed skeletal systems with more bones and a more protective design than the other classes of the phylum Chordata, as an adaptation to protect not only larger but more organs that these mammals are equipped with. So, that pretty much concludes our lesson of the skeletal systems within the phylum Chordata. Hope you learned a lot, and if you did, don't forget to like and subscribe.